everyone, and welcome to our next Data Zen community event. And my name is Andrei. I will be hosting this event today. Thank you all who joined our session, and I'm glad to introduce Artem Gasparyan, Senior BI Analyst at EPAM. Artem will talk about AWS services for data engineering. And before we start, please post your questions to the chat during the session. We will address them at the end of the session. And Artyom, the floor is yours.
Yeah, thank you, Andre. Thanks so much. Hi, everyone. So today we are going to speak about modern data engineering with AWS, and we will have a look at some concept, but also we will go to real life pipelines and see how everything is working there. So a little bit about me. I'm a senior BI analyst that already presented, and I'm a certified AWS data engineer. I have 6+ years of fueling insights with data. So I worked on different projects for different companies, but for highlighting is the one that I have worked with #1 financial rating agencies in the world, global scale marketplace, and there were leading banks which were powering their data decisions with terabytes of data. And I worked also in an AI project for the oil and gas industry. We revolutionized the way that that industry was looking at the data. So if you will have any questions, don't hesitate, just contact me. And in the end, I will provide also my LinkedIn QR. And today's agenda is to have a look why AWS is important, what key services we have for data engineering, and not only, and how these services work together as an architecture. And when we talk about the data, we always should keep in mind that the data processing, keeping, and decision-making should be secure and powered with best practices. And all of these should be also accompanied with cost management and monitoring, because if you do really good data engineering, you should also keep the costs low. And we will have a short demo how everything is working, and we will give you some time for your questions. So let's get started. And why AWS is so important? Because AWS is the #1 cloud provider in the world. So when we heard about innovation in the cloud ecosystem, AWS is the #1 that we can think about. And if that innovation was not made by AWS, we are sure that in some days, in 2 days, AWS will come up with its solution. And why it is so important to think about cost efficiency? Because AWS is providing all these services, most of the services pays as you go. So you only pay for the time and for the resources you asked. And sometimes people think that if we are moving our data or our processing to cloud, it will not be secure. But anyway, to keep all that security by ourselves in our own servers or on-premises solutions is much more harder than we can trust AWS. And we know that AWS security is very high. And sometimes if something is happening on your services, in your servers, and if you don't notice it, AWS support will come and say, we have identified these issues, and we logged these keys or these security things for your security. So it also provides high security and agility, because you can really quickly deploy your applications, use different services from different regions, and it's very easy. And in current days that we have an AI, the solutions are coming very fast if your business needs it. So AWS is the #1 to go, I think. And when we talk about data engineering, we cannot think about the storage. So the primary storage that AWS is providing is Amazon S3. This is the key service for data engineering, because we need to keep our data somewhere with cost-efficient way that we can also get access to it very quickly. S3 is an object storage, which means that you only keep your files, things like as an object, and you can just delete it or re-upload it. You cannot edit your files like directly in S3. What is interesting about S3 that you have a lifecycle management. What it means that your data can be accessed differently. Like some data need to be accessed in milliseconds, and some data should be just kept for some backup situation or some internal audit or some data governance things. And you just need to have them, but you don't need to access it very frequently. And it means that you can change the type of storage and have much more efficient cost way, like 98%. Like you can go from Amazon Frequent Exer to Amazon Glacier, which provides really low costs. And sometimes you need to also keep in mind that somehow wrongly someone can upload a file, but that was wrong and you need the previous version. You can keep also versioning of all your files. But keep in mind that this feature, if once it's turned on, you can never turn it off. And this is very good feature, but it also adds cost because you just have multiple versions of the same thing as a versioning. And why S3 is very important, this storage provides us notifications triggering, like once your file is uploaded, deleted, updated, or anything has happened, any action with your files, it can send notifications. And why it is important? Because in the serverless data engineering, everything is running once it is triggered or notified. So when we talk about data engineering and AWS serverless, this is the primary thing, because if our file or our data is on S3, we just trigger our codes, our pipelines to work, and they are not turned on when we don't have any actions or notifications. So S3 is very good and can be used for backup and for data lake and for archiving the data. Some advice from my experience is that you can use S3 as medallion architecture and keep your data engineering data in this structure. What I'm offering is that you can have a raw folder. In the raw folder, you can have your data organized with dates, the same with bronze, silver, and gold. This architecture is very helpful when you are handling with data engineering, and you can organize this structure in S3 with folders or even with different packets. And from my experience, what I'm doing, and I'm adding also to this architecture failed folder, which means that every time your data is failing for some data validations issues, you are keeping also the failed layer, and you can go and track why that was failed in which date, like failed in bronze layer in this date. So this is a very good way to keep your data engineering clear and data access even we can say proficient. So clear separation, easy tracking, and scalable. One thing that we also need to think about when handling with data and S3, because S3 is allowing us to keep our data not only in CSV or in Excel or TXT files, but also Parquet files, which are the columnar storage. So in the data engineering world, we have row-based data types like CSV, Excel, TXT, and we have columnar files like Parquet files, which is interesting that if you are keeping your data in S3 with CSV or Excel, something like that, every time you need to access your data or process your data, you need to download whole file. Like if it will be 1 gigabyte CSV, but you need only 2 columns from that CSV, you will need to load all the data. And you are paying for data transfer and you are paying for the processing. So if you are keeping in a raw way based data type, so sometimes you are just paying for nothing. When we are talking about Parquet files, columnar storage, the S3 is allowing us to get access to specific columns in our files that we need. Like you can keep the same CSV file as a Parquet file and get access to specific columns and download only that specific data and not pay for downloading data or longer processing. This is a very good way, so keep in mind that it's very good best practice. But one thing that is not good with Parquet files that they are not human readable. They are binary files. So every time you need to have a look what you have in Parquet file, you need to make it like CSV or any other files that is human readable. But for all that processing, it's very good. And if you think also about serverless querying like Athena, and this is also very good because when we are handling with Parquet files, Athena is also accessing to the columns that you need specifically, and you pay less, and you pay less to the processing also. This for the storage. But what about like Lambda? What is it that? So we are thinking about serverless, yeah? And serverless is like one service we should think about is the Lambda, because Lambda is allowing us to write our code, like very short piece of code, some data engineering, transformation, things like that, uh, and process our things based on notifications or triggers. So imagine once our file is uploaded to S3, S3 notification is sent to Lambda, and Lambda is triggering our code, and it happens not as like 1 second or 2 seconds. It is happening in milliseconds. So the Lambda is designed for data-driven workloads. Common sources of triggering the Lambda can be S3 notifications or Amazon Simple Notification Service or Q Service, and even databases like DynamoDB. If in DynamoDB there is a new row added or the row was updated, that can trigger the Lambda to process something. For example, if we are keeping our passwords in DynamoDB and that password was updated by the user, and that can trigger the Lambda to send the user an email saying, okay, your password was successfully updated. There are lots of use cases with Lambda, but today we are looking for the data engineering use cases. So the one workflow is that I described is that you are uploading your file to S3, that is triggering the Lambda. The processing is happening. For example, you are uploading CSV file to S3 and you want to transform into Parquet file. This Lambda is triggered, the file is transformed to Parquet and stored back to S3. Very good use cases for Lambda is the near real-time processing, data quality checks, ETL automation, and different other use cases that you can use Lambda for. But as we know, there is no a perfect service or solution. So the Lambda also has its limitations and some technical things that we need to take into account. The good thing is that it's supporting the most of the common programming languages, but your Lambda can only run for 15 minutes, no more. So if your pipeline or your code needs to run more than 15 minutes, we will later have a look to other solutions like AWS Glue. And your memory allocation can be up to 10 gigabytes, no more than. And your local storage, again, can be 10 gigabytes, no more than that. And one thing that is sometimes killing some pipelines that you need to engineer in Lambda is that your deployment package overall code should not exceed 250 megabytes. And you think that it's quite big, but not always, because sometimes you are just including different packages that are big for geo exploration, for big analytics. And sometimes your code is really hitting that limit. When we are thinking about layers, there are some libraries, things that you are connecting to your piece of code that it can run, and you have only 5 layers. And also Amazon is providing its own layers, and sometimes they are very big. So if you are adding one layer, for example, pandas along with different other packages, they are already hitting that 250 megabytes. But there is always a different way to go. One thing that I have done to not hit this limit and to really bypass it, you can keep your packages in S3, and every time you are triggering the Lambda will download the file from S3, that packages, and process it. So this limitation you can bypass. But when you have your cloud, private cloud, it will be free, because if you have your VPC installed and engineered on AWS, all data transferring in the same region will be free. But if you don't do that, so every time your Lambda is triggered and it's downloading the file from S3, probably you will pay for that data transfer. And yeah, probably for Lambda, it is that. And once your Lambda is triggered, sometimes it is keeping its hot state, which means that your Lambda is somewhere deployed with its code, and it's not every time downloading everything that you need. Like if your Lambda is being triggered very frequently, they are always in a state that they can be just very quickly processed. So AWS is handling that as well. And we cannot think about serverless and AWS data engineering without AWS Glue. So this service is very large one, but in short, we can say that this is the primary service to use for data engineering. And once you have much more big data and you want to process all that data in an efficient way, you should go and use AWS Glue. Again, it's serverless. You can write your code, or you can do your pipelines transformation, like getting data from this data source, transforming it, making aggregation, grouping it, anything you think, with visual way, so without no coding. Also, Glue is providing that. But in Glue, we have also serverless querying service, which is Athena. We have data catalogs, which keeping our data catalog in AWS Glue, and you can see where you have data in which format, in which way. So this is the best way to go, and it doesn't have that 15 minutes limitation. It has its limitation, but it's much more longer, like it's 48 hours. And yeah, AWS Glue, we can think like that. For bigger tasks, you can use AWS Glue. And what I am doing from my experience is that if I am having a very large file that I need to process, firstly, I do it with AWS Glue. Then I split it into parts. For example, if we have millions of rows, I can split it in ranges, we can say in batches, like 50,000 for each. And I can save that file separately on S3. And when I am saving that, for example, 10 or 20 files separately in S3, once the file is saved, they are triggering the Lambda. And the Lambda can be triggered simultaneously, like thousands of Lambda. It means that we are having simultaneous processing for 20 files. And 1 million records are processed very quickly with 20 Lambdas. So this is also a good way to do with AWS Glue. But AWS Glue is not providing all that programming languages we could see in Lambda. We can use Python and Spark, but they are very good for data engineering. We can see all these limitations, but for sure, if you need like streaming data, if you need much more larger processing, you go and you use AWS Glue firstly, and then you can engineer some small pieces with Lambda. But all these things that we are discussing, it's very good to think about also how your data is traveling from one place to another. And this is when we should think about VPC. Amazon Virtual Private Cloud is allowing us to have our services in our engineered cloud, architected cloud, and it allows us to have our data processing in a secure way. So in Amazon VPC, we can think about like it's your way of saying Amazon how one thing should connect to another and how the data should be processed from one place to another. Actually, in higher level, we are having public subnets and private subnets. And how we differentiate them is that public subnet has access to the internet, private doesn't have. And when we are calling like a private subnet or segment, and we are giving an access that subnet to the internet, it automatically becomes public. Doesn't mean that we named it private and it stays private. And for sure, we can have data internet access from private subnets with NAT gateway, which means that private services can have internet access to the internet, but from the internet, they cannot be called that services. So why we are talking about VPC? Because you need to set up once this, it's not that much easy, but once you do that, later it becomes easy. So you need to have your private subnet in the AWS, process your data in a secure way. When you are having this VPC, you are telling AWS how your data should be transferred, which means that for your data transfer, AWS is using its local network, which means your data is not going out of the local network of Amazon. So it's not traveling via internet and no one can access it. So that's why please set up a VPC, process your data in a secure way, keep your data a secure way that you can access it. And also AWS is saying that if you are doing this VPC setup, you will not pay for the data transfer in the same region if your services are talking. For example, if you are having a database, Lambda, etc. in the one region, and you have lots of data transfer, you can also benefit from that cost efficiency because you set up the VPC. AWS knows how your services is talking to each other, and you are not paying for the data transfer between them. So most common use cases for having VPC is the data lake isolation. So you are like keeping your data processing storage in a private subnet, and only, for example, the web application can access to your private data from public subnet, but no one can do it from external sources. Yeah, this is a technical way how to do that. I will keep it in the presentation that you can later have a look, but it's easy, and nowadays with AI you can do it very quickly. Not big thing, but once you are doing it, it's a very best practice. Later you are just using your virtual private cloud, and you are happy with that because no hacker can easily access to your data and your data is secure. And we should also talk about SNS and SQS because we have seen that S3 is sending notifications to Lambda or to other things as well as SNS, SQS, but never we can track if that notification was sent or not, or when it was sent, it is in which situation. And SNS, SQS, and SQS are coming to help to visualize all that. So first of all, SNS we can use to trigger again our Lambda, but we will see what type of notifications were sent and how they were distributed between the Lambdas or other services. And SQS is providing that queue service because sometimes we need to not process everything at once. For example, we have Lambda limit of 1,000 simultaneous Lambda can work, and sometimes maybe our workload is higher than 1,000, so we need to have some queue. That 1,000 are processed, next 1,000 will be processed after that. This is a very good way of doing also, and it gives much more visibility, but it adds cost. And also why SNS is very good, because we are having also different types of notifications, such as email, SMS, or mobile push. So it's very good, but what I can advise is that don't sometimes over-engineer, over-complicate your workflows. If you are having like some files that are coming to your storage and you need to process it with Lambda, then in real time insert or update your database, not always you need this SNS. If it's small, not very big architecture, you can go without SNS, as we can see later. How these services work together. So you can see here that users are uploading, for example, an image. Like when we are going to an application and they ask us to upload an image. We are uploading our image. That image is stored in Amazon S3. and it is sent, for example, a notification to Lambda. We have, for example, a role layer when different big images can be uploaded. But later we have Lambda saying, okay, doesn't matter what type of image is uploaded, please transform it, make it like, for example, 2 megabytes maximum, and store the image in this bucket. So the notification is sent to S3. The file is uploaded to S3. Notification is sent to Lambda. Lambda process the file, saved in different bucket, for example, resized images, and sent a notification to on Amazon SNS as well, that it can send email or push notification or anything saying your image was uploaded successfully. But in this architecture, as you can see, we don't have a VPC, which means that all these things are happening with internet. So the data transfer is done via internet. But we can adhere to a VPC to not overpay for data transferring. And we don't see here a glue service. The glue service can be somewhere here. And in our demo, we will see it as well. When you have a much more larger file that Lambda will not be able to handle it, or you need to do pre-processing before passing it Lambda, you can add also a glue here. Yeah, probably for the architecture and workflow to keep simple, it was this. And yeah, the security best practices that we need to think about is that please give access and users roles to your AWS as much as they need, and don't give too much permissions, because if your, for example, user or your access token was stolen, they can just connect to your AWS account and do whatever you want. So keep the user differentiation very clear and serve this only they need. Don't give just them an admin role and say, do whatever you want. Use encryption, which means that your data transfer is happening with encrypted way, and your data will not be accessed and opened in an easy way when it travels via internet. Use also access controls. So when we are talking about VPC, you can access to different services with different security groups. Not every service have access to all services in the VPC. So please engineer your security groups in a way. And if you are having some access to your VPC from outside, for example, from your office, just whitelist your office static IP. Don't whitelist anything, or don't just open services to the internet, even if someone is asking you to do that, because for their easy way to do that, they are asking, please open it for once, then we will close it if something is happening. If something is happening, it happens once, and your solutions are just stolen or killed. So there's a concept of saying bastion host, which means that your VPC and your private cloud is very good engineered, but you need sometimes to access your private services from outside. So you are just implementing a small servers in a public subnet, which named a bastion host, which means that you are connecting to that server, and that server itself is connecting to your private services. Why it is very good? Because you can access to that bastion host from anywhere, and if something is happening and someone is can take your bastion host, or find your secure key, or can connect to your bastion host, just from AWS console, you can go and kill bastion host, and your VPC still is secure. So this is a very good way to go. And yeah, there are other things to do, but all these things are for the security and best practices. Please follow them, because again, I will repeat myself, but if you are doing data processing, data engineering, and you don't think about security, why you are doing that? So keeping data in a secure way is the most important before doing any data-driven engineering or decision making. Yeah, and when we talk about cost management and monitoring, we should think about that serverless is not free. You are paying for the resources you asked and for the time you have run. So you can configure your Lambda RAM storage, local storage. So please keep it very tiny. Like you can allocate RAM like 10% more or less. So why I'm saying that, if you are just doing small processing, you don't need to allocate 1 GB of RAM to your Lambda. Just allocate as much as it needs, because you will just pay it for that. And in order to monitor it, you can go always to CloudWatch and see how your Lambda is working, what was allocated and what was actually used. And be strategic, yeah, because triggers are very good to have a real-time processing, but keep in mind what type of triggers are you using. Because if you are using like all the type of triggers, what is happening with the file, like you can trigger the Lambda when it's not necessary. So you need also to keep in mind which triggers are triggering what type of Lambda. For S3, for your local store, for your storage, you need to think about like what the data you are keeping. Do you need that? Because you can just put lifecycle management saying for after 2 weeks, if the file was not accessed, please delete it or change to different tier. So also always monitor your S3 and understand what type of data you need there in which tier, because generally every company is keeping in the same frequent tier, which is very expensive, in comparison with other tiers such as Glacier or other things. So you just need to know how your data need to be stored, and you can save your money. As I already said, you can optimize your Lambda when tracking your memory FMO storage with CloudWatch. Resize it as you think it needs. Glue, always look at the glue, how they are running, and don't put so much time for that, because, for example, you know that your job should not run more than 15 minutes or 30 minutes. Don't put your running time like 48 hours or 1 day, because maybe something, a bug is happening in your code and it just continue runs without any result, and you are just paying for that. So it's also a good way to limit the job run time limit, because if it will be automatically killed after that time is reached, so later you can understand why it was happening and correct your code. As already said, if you are setting up a VPC, you will not pay additionally for data transfer in the same region. And for more data-driven billing way, so you can get the detailed billing reports to your S3 from AWS. It says really very detailedly how your billing was calculated. You can also connect the CloudWatch metrics to that billing, saying at which time that Lambda was run, at which RAM, how much resource we allocated and how much actually was used, and get AI-powered insights with your cost management. So you will see where you are paying how much and how you can make it better. And also this is very good because AWS is giving very detailed billing. So once it is available in S3, you can have an Lambda, processing it, grouping it, changing it, joining with different types of information, and just inserting in your database for your data, for your business intelligence. And you will have near real-time data. So hopefully you are ready to see everything in action. Let me just go and make a small demo for you, because we have talked so much that we can just have a look how everything is working. 1 second. Oh, yeah. Hopefully you can see my screen. So what we are seeing here is that we need to get the data processed and transformed in AWS and be accessible for for our business, imagine. So we have this data. We are using the API to get this JSON, which is saying that what type of companies are top gainers in the trading industry. So what type of volume of shares they are providing, what was the change amount, the price, and the ticker name. So, and we have this data organized in 3 sections. So we have top gainers. Later we are going and seeing top losers who have lost in the financial market. And we have also most actively traded, like the most volumes that was transferred from in the financial market. So imagine this API was, for example, given us from our customer or from our team and saying, guys, you can use this API to access the data and to transform the data and see the business intelligence in a way that you want. So here's our API, and the API key is visible here, but it's okay. It's a public key. Everyone can access this API, and it's a public API. So first of all, what we need to do is to go and see how S3 is designed. So the local storage, we have this bucket, so AWS Serverless demo arm. The bucket name should be unique in all AWS environments. So in the world, there is only one bucket named like this. So the name is unique. And architecture, as I was presenting you, was like this. So we have raw data here. In the raw data, we have date folder saying when the data was transformed, gotten, and here we have the data. And the same is for bronze, silver, and gold. So first of all, we need to have this bucket to store our data. To do that, it's very easy. You are coming here, creating your bucket, giving it name, the ownership, and as I was saying, the versioning. You can disable or enable versioning, adding tags, encryption, etc. And you are creating that. Also, please keep in mind that always check the box that your S3 bucket is blocked for publicly access. So you can set up different ways of accessing your data from public network. So we have our bucket here. The next is to go and to set up, for example, a glue job, which will get this data, transform it in a way that we want. And that later our lambdas can process it. So we are coming here to ETL jobs. We can do it visually, but I prefer a code. So yeah, here's our top gainers code. It's just very simple code saying go and get the URL, the API, hit the API, and save the data in a JSON format. Because what we know, firstly, we should keep the data in a raw format, which means we keep the data as we received it. And we have here the job details. So it's a Python 3.9 and how it should run, and etc., etc. And even the data processing units, how much resources we allocate these, the minutes time. And I will not, I can go also a little bit here that you can see that also you can keep your environment variable secure way, like job parameters. But also there's other services that you can keep your environments out of the code, as we were talking about the security. And before running this job, let me also show you how the Lambda is designed. So we have here 3 different Lambdas. One is that once the data, the glue is running, the data is stored in the row here. It is triggering the row to bronze Lambda, which is actually, if I'm not mistaken, splitting the data in 3 ways. Like we had their top gainers, top losers, and most traded. So we are splitting that groups into 3 groups to save in the bronze folder. Later, we are having another format that is just changing and making a validation saying that every row should have a value. If some row doesn't have value, so it just drop the data. So it's a validation step. And in silver to gold, we are just transforming the data from Parquet to CSV that everyone can read it. What I want to say is that, yeah, for creating Lambda, you are coming here. The Lambda name can be whatever you decide. You are choosing your code. What should it be? And yeah, later, once you are creating the Lambda, you are having this view. So here you are putting your code, and like you can just copy and paste your code here, but also you can do a CI/CD pipeline that it's automatically coming your code here. Just need to be integrated with GitHub and Actions. You are having your configurations here, how much memory and storage you are giving it. You are configuring permissions, VPCs, etc., and how this triggering is working. So what I'm doing, I'm firstly creating a Lambda, and then I'm coming to here, to my backend. I'm coming to properties, and here there is a section about notifications. And I'm coming here, we can just, for example, edit this one to see how it works. So we are saying from where it should be triggered, like from bronze / it means after this thing, what is happening, it is triggering. We have a suffix to keep us secure to not trigger everything. We need only to trigger .parquet files. We are saying that all object creation events should send to Lambda. It means put, post, copy, and multiple upload. There are lots of other notifications, but we are skipping it. And in the end, we have a way of saying what thing should be triggered, like we are triggering Lambda, or we are sending that notification to SNS or SQS. Here we have choose Lambda, and we choose our Lambda from the list. Yeah. So let's see this in action. Why I was doing all this in order to also show you how these things is working. So we are coming here, running our job. Okay, it will take some seconds, but let me go here to the row folder, because here it will be created a very today's folder. And later, we will track also how fast the Lambda was triggered, because you will see that instantly when we are saying real time, it really gets the data in a real time to different buckets. Okay, 20 seconds, it is succeeded. We are refreshing here. The folder was created. So we can see that our object was here. And we are coming back to row, and we are coming to gold. Okay, already data is here. We have most actively traded, top gainers, top losers CSV in just milliseconds. So if I'm downloading this file, okay. 1 second. The file is not coming to that screen. But yeah, I mean, 1 second. Okay. I was somehow able to do that. Tricky. Okay, I'm not able to move this file to your screen that you can see, but we have these 3 CSV files. So the data was just split in this way, kept in a raw format in CSV in files. And yeah, as you can see, the data was gone through a network, through different folders. Like we have raw, then we had silver created just after that. And because the Parquet is columnar format, it keeps in folder as well. So here it is. And yeah, I mean, it was very quick, fast. And when we talk about serverless and about real-time processing, we mean this. And yeah. So this was all for today, guys. And now we have Q&A session.
Thank you, Artyom, for this detailed introduction. I believe it would be very useful for BI people and data analysts who are not familiar with AWS services for data analytics and data engineering. And thank you for this great demo. And we've got several questions from our audience. Thank you, Shamil, for being active in our chat. So the first question is, what do you think about S3 table? You've talked today
S3.
about S3 buckets where we can store our files like CSVs, parquets, but there is also an option to use S3 table in AWS.
Yeah, it was recently introduced. To be honest, I don't think that S3 the table, I never used that option, but I mean it can be also a very good option to use in the data engineering. But as for now, I was using just the storage, which is very good, as I already explained, for columnar processing, for Parquet files, for Apache and Spark processing. So yeah, I don't have too much examples with S3 tables, but S3 storage still offers the most cases are covering with S3 storage. Yeah.
Mm-hmm. Yeah, I can add that S3 table have some few fancy features like it can automatically optimize your data to keep query performance at the same level when the data is growing. So it could be a good option for big data sets which we are refreshing regularly and the data is growing fast. Okay,
Yeah.
thank you. The next question, what about durable functions in Lambda? So you've told that Lambda can run only 15 minutes, but recently AWS also introduced a feature for Lambda functions, which is called durable functions. Can you
Yeah,
comment on this?
this is introduced recently, and even AWS has recently introduced also that the Lambda we couldn't, like, it was AWS serverless services, and you will not was able to allocate a specific EC2s to that, and like have your, because the Lambda is running traditional Lambda is running on the servers that AWS is choosing, but now you can choose by yourself and allocate your servers EC2 to Lambda. These new things that AWS has provided, it's cool, and it's answering to the market demand, because okay, 15 minutes is great, but sometimes things are happening and 15 minutes can not allow us to do whatever we think, and we are going back to EC2 servers or Glue. So yeah, I mean, for me, I was always doing a batch processing, splitting everything in small pieces to not hit that limit. But let's see in action and in use, in experience, how this will work. But it's very good that AWS is hearing us and helping us to not overcomplicate our life. I think it's very good.
Mm-hmm. I had experience with Glue to set up a job which can run for a while and at a lower price, and the solution was to use Python shell jobs in Glue. They are very cheap, so it can cost
Yeah.
just few dollars a month if you configure it properly. So
Yes,
those
yes,
durable
actually,
functions
yes.
is a kind of extension of this possibility to AWS
Yeah,
Lambda.
yes.
Okay, thank you. The next question: have you tried the S3 vectors? The
S3
one more
vectors.
new feature for
Mm,
S3.
Yeah, it's like helping us with LLM. I haven't still not tried because like for large language models, we need to keep our data in vectors, yeah, and embed them
Mm-hmm.
and keep them. So this is a very new feature that it's good because until now we have been using our like vector databases, and now yeah we can store our data in vectors in S3. Haven't still used it, but as we go with the agentic AI solutions, probably it's a good way to also have a look on that. But I mean, it's promising. Sounds promising.
Mm-hmm. Yeah, I'm agree. Okay, next question. Have you tried to use Bedrock to make actions in data pipelines? For example, to find the PII data disclosure
Mm.
and etc.
Yeah, I mean, the Bedrock is very good that APIs that is not actually in the pipelines, but I have used with LLM, like you can standardize your data with LLM. So yeah, not specifically Bedrock, but again, the Bedrock is just providing APIs. So we have now, if I'm not mistaken, Amazon is providing also a Quick, which is also doing that with Bedrock and identifying the data. But integrating LLM in your pipelines is very good because I have used it for replacing the regex. Sometimes you were doing like very complex regex to understand if you have that data in that column or to make a grouping, etc. But now you can just very good configure the LLM, give your data and saying, for example, look at this text and understand this refers, for example, 20 out of 20 possibilities, which one is best describing this. And LLM can do it for you. And also, yeah, identifying that personal data. Um, I haven't done it, but sometimes we need to be just very careful with that because where your large language is deployed is very important when you are passing your personal identifiable data. Like the Bedrock is providing the APIs, but you need to make sure that you are uh, in accordance with data governance. Like for some countries, you need to process if you are using LLM in the same country. For example, in Europe, the data cannot be go out of Europe. So yeah, please pay attention to that. But you can for sure use different LLMs and APIs in your pipelines to get work done easily.
Mm-hmm. Thank you. Next question. In your example, is function always running to have an immediate response?
No, actually, what is happening, like the Lambda is not always in the hot state, which means it's not always deployed somewhere. So AWS is doing that job in our place. So, but what is saying AWS? So, for example, today I haven't run AWS Lambda that code, and none of them. So it was in cold state. Even in the cold state, as you can see, it ran very quickly. But what AWS is saying that if your Lambda was run like for now, we have run it, it probably it doesn't deleted all the resources from the server. And if we are running again, so it will use the same deployment as for the previous one, which means it will be in the hot state. So the triggering will be happening in instantly, even quicker than previous one. So it was not running always. It was just there because we are talking about serverless. It is running when we are triggering it.
Mm-hmm. I see. Thank you. Hope it answers Sergey's question. So the next question from Sergey is Lambda the only serverless service? What are other options and differences for serverless?
No, for serverless, as we presented also, we have much more serverless services in AWS, but the one was that can replace the Lambda is the Glue, which is the primary data engineering serverless service in AWS. So it is providing much more capabilities. You can search your data, crawl your data, and then there is a AWS Athena that I really love because you can like set up with AWS Glue. For example, if you are keeping your files in Parquet formats, you can go just make a crawler, make a database in AWS Glue. It will be just stateless, simple thing in AWS Glue, and then use AWS Glue, AWS Athena, which is a serverless query. So you are running SQL queries on your files in S3, just like that. And you don't need to just set up a database and try to run the queries, because in my situation, sometimes I'm having very big Parquet files, and I haven't. I made processing on that Parquet files and inserted some data in database, but I don't have all the data as we saw the raw data. So, and sometimes customers are coming and saying, we need to have a look on this and this. And I'm just using that Glue plus Athena to query that Parquet file once and do not make other complex things.
Mm-hmm.
And there are lots of other serverless services, because it's very good because we are paying as we go for the time we use it. So we are trying to, Word is trying to move the architecture to serverless.
Yeah, AWS provides a lot of possibilities to use serverless, but usually the question is how expensive they are, and
Yeah,
for some types of data pipelines, it's better to use upfront prepaid instances if we are running 24/7
yeah,
and serverless, and it will cost much less. Like AWS promises now they promise 72% cost reduction in case of 3 years upfront EC2
wow,
instance.
yeah,
So
amazing.
for big projects with huge data load and processing, it might be a big plus to switch from serverless to
Yeah,
prepaid
options,
instances.
instances. Yeah,
Yeah, thank you, Artyom. We run out of time. Thank you all who joined us today. I hope you enjoyed this session, and please don't forget to rate this talk on our community page, and also give our speaker a badge. And I hope you will be enjoyed with our next events, which will come soon. So please uh, check our Data Zen community page for more events like this. Thank you, Artem. Thank you all.
thank you, Andre, and thank you, everyone. Have a nice day. Thank you.
Have a nice day. Bye bye.
Bye.